Pipin, let's start our topic now. Pipin, can you hear me, dear?
Okay, sir. Yeah.
Okay, let's start our discussion for IPv6 today. Okay,
Okay,
IPv6.
sir.
I think other students are not available. So OSI model we will start tomorrow. Okay,
Okay. No problem.
let's focus on next generation IP implementation. This is called IP version 6,
Yes.
IPv6. So why we need IP version 6? Because if you remember, in IP version 4, in IPv4, we have 32-bit. In IPv4, we have 32-bit. And this 32-bit, you can change in decimal. If you want to put this 32-bit in computer, so you can change in decimal value. Now this is the format. This is the format for IPv4. A dot B dot C dot. And this is called what? This is called octet. And in every octet, we have 8-bit, right? Fabian, in every
Yes, sir.
octet, we have 8-bit. And if you remember our discussion for IPv4, in IPv4, total IP address, we have approx 4 billion of IP. Approx. Aniket, can you hear me, dear? Aniket?
Sir.
Okay. So in IPv4, we have approx 4 billion of IP. And IP managed by INA, right? IP managed by INA. Internet assigned Number Authority, INA. Internet Assigned Number Authority. And INA divided all the IP addresses in classes. And we have class A, class B, class C, class D, and class E. Okay, this is IP version 4. Okay, this is IP version 4. Why we need IP version 6? Because we have approx 4 billion of IP address. Too much IP address we have in IP version 4. Why we need IP version 6? Okay, so now if you go with the technology, okay, now all the devices are IPv6 enabled. Your mobile phone, your IP camera, right? All the devices. Most of the devices are IPv6 enabled. Now we need IP address not only for computer communication, device communication. We need IP address for example, for IP camera, okay, for network printer, okay, for other appliances, we need IP. So that's why we have IP version 6. It's called next generation IP. Next generation IP. If you compare with IP version 4, in IP version 6, what we have? We have 128-bit in IP version 6. 128-bit. Okay, and if you want to configure this 128-bit in computer, so you can change in hexadecimal format. Hexadecimal format. Now, what is the format exactly in IP version 6? This is the format: A colon B colon C colon D colon E colon F colon G colon H. So it is separated with colon. And this is called field, everyone. This is called what? Field. IP field. And in every field, we have 16-bit. So we have 1, 2, 3, 4, 5, 6, 7, 8. We have 8 field, and in each field we have 16-bit. So 16 multiply 8 is called, we have 128-bit. Total IP in IP version 6, what do you think? Total IP in IP version 6, let me show you. Total IP in IP version 6 in next generation. Sumit, can you hear me? Sumit? Sumit dear, can you hear me? Okay, this is IP version 6 slide. Okay, wait.
Yes, sir.
Okay. So total IP we have in IP version 6.
Yes, sir. Yes, sir.
Okay. Please turn off your mic. Sumit. Okay. If you have any question, you can unmute. No problem. Sumit, can you hear me? Please turn off your mic. No. So total IP we have in IP version 6, big number. A big number. Aniket, Fabian, Sumit, see, we have a big number. Aniket, in IP version 6, we have big number. See?
Yes, sir.
So this is what? Next generation IP, everyone. Next generation IP. Okay, let's go to here. So total IP, we have a big number in IP version 6. Let me show you the format, everyone. Okay, let me show you the IPv6 format. So format is what? I'm trying to use one IP here. So 2001 colon 10 colon 10 colon let's wait. 0011E colon 2EAC colon 0000 colon 1ECA colon 2EBA colon 0001 1 2 3 4 5 6 7 colon 5E2C. So this is one IP, everyone. This is one IP. And for example, if this is your machine IP, okay, and I want to ping you, what do you think? I will use ping command and this big IP. This is IP version 6 format, a single IP. Now you can use this IP in a compressed format. This complete IP you can use in a compressed format. So you can use 2000. You can use 2001 colon. This 0 you can compress. So this is 1E colon 2EAC colon. So now you can see this complete field is 0. So you can compress this. So we have colon colon. Now 1ECA colon 2EBA colon. Now you can compress your 0. So 1 colon 5E2C. So you can use this complete IP address into this format. So in IP version 6, we can compress 0. Let me show you one more format. One more example. Okay, I have this IP. Okay, let's go with this example. For example, here we have this one. This field is also 0, for example. Complete field is 0. So now you can see in your complete IP address, double colon you can use on a single line. In a complete IP address. You cannot use double colon on multiple time. No. So yes, this 0 you can compress, you can use double colon, but here this complete field is 0. So you need to specify your 0. You need to type your 0 value. You cannot use double colon multiple time in IP version 6 IP. Okay, if you have multiple fields 0, so you cannot compress with double colon. No. Double colon you can use on one time. And this field is 0, so you can type a single 0 here. Let me show you one more format. For example, I have IP 2001 colon 1/64. What is 64? If I have a 64 here, 64. 64 means what? This is what? This is prefix value. This 64 is called what? Prefix value. So 64 means what? This first 64 bit is a network portion into this IP, network portion, and this last 64 bit is a host portion. Host portion. So it's the same. You cannot change your network portion, but you if you want, you can change your host portion, no problem. Now here we have example for IP address 2001::1. This is complete IP. Aniket, Fabian, Sumit. This is complete IP version 6. What is the actual format? Actual format is 2001::00:00:00:00:00:00:. एक दो तीन चार. Yes, 8. So we have actual, this is the actual IP address. And you can compress this complete IP address into this format. So we have contiguous 0, contiguous field is 0. So you can compress with only double colon. Clear this format, Aniket, Fabian, Sumit?
Yes, sir.
Fabian for you, Sumit?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Now, in IP version 6, we don't have classes. No. In IP version 4, we have a classes, but in IP version 6, we don't have classes. In IP version 6, we have IPv6 unicast address type. Okay, let me show you. So if you talk about IP version 6, we have address type here. Address type. This is our topic, unicast. Okay, you can say IPv6. You can say IPv6 unicast address type. So we have 3 address type in IP version 6. The first one is what? Global unicast. Then we can go with unique local, then link local. What is global unicast address type? What is global unicast IP address in IP version 6? Your public IP. Your public IP is called global unicast address in IP version 6. Okay, public IP. And right now, IANA is using Internet Assigned Number Authority. IANA is using IP address start with 2000, start with 3000. So in a real network, right now, in a real network, you can get a IP version 6 IP, okay? And if you have public IP version 6 IP, so it's always start with 2000 or 3000. So right now, IANA is only using 2000 range and 3000. IP address start with 2000. So if you see IP address anywhere which is start with 2000 or 3000, you can say it's a global unicast IP, or you can say it's a public IP. Unique local, this is your private IP. It's like a IP version 4. In IP version 4, what we have? We have private IP address range, right? In IP version 4. If you guys remember our NAT discussion, in IP version 4, yes, we have a separate range for private IP. In IP version 6, yes, we have unique local. In IP version 6, yes, we have private IP address. And this IP address is not routable on global network like internet. No. This unique local IP, this private IP, you can use in your private network. And how you can identify this is unique local IP? Like in IP version 4, IP start with 10.0.0.0. This is private IP. In class B, 172.16.0.0. In class C, 192.168.0.0. So if IP start with 10, 172 or 192, this is what? This is private IP address in IP version 4. In IP version 6, it's always start with FC and FT. So if you get any IP address which is start with either FC or FD, you can say it's a unique local IP, private IP in IP 106. What is link local? What is link local? So it's like a APIPA. It's like a APIPA concept. What is APIPA? APIPA. APIPA. Automatic private IP addressing. So if you have a computer, for example, if you have a computer and this computer is connected with a switch, okay, and in your LAN side network, you have DHCP server. DHCP server. What is DHCP? I will tell you in TCP/IP protocol suite. What is DHCP server? Through DHCP server, you can provide IP address to your LAN computer dynamically. So my point is, in your network, you have DHCP server, and this client, on this client, you don't have static IP address configuration. Okay, in client LAN card, you don't have static IP address configuration, and you are using dynamic option, but you are not getting IP address from DHCP server. Maybe some issue. I don't know what is the issue, but you don't have static IP, okay, and you are not getting IP address from through DHCP server, so you can get a IP address from APIPA. APIPA range we are using for troubleshooting, okay. If your client is getting IP address from APIPA range, so you can say there is a connectivity issue in between client and DHCP server. Okay, if you are getting IP address from APIPA range, and APIPA range is what? 169.254. So if you are getting IP address from this range, okay, your computer is a part of DHCP network. Okay, you are waiting for IP address through dynamically, but you are not getting IP address. So maybe it's a connectivity issue. How you can say it's a connectivity issue? Because you are getting IP address from APIPA range. It means there is a connectivity issue in between your machine and DHCP server. So in IP 104, we have APIPA, automatic private IP addressing. In IP version 6, it's called link local. In IP version 6, this is what? Link local. Every IPv6 enable interface will get this series of IP. And APIPA range always start with FE8. APIPA range always start with FE8. Let me show you, for example, let me show you. If you check LAN card setting, if you check my LAN card setting, wait. You can right click on any LAN card, go to properties. Okay, Internet Protocol, TCP/IP version 6 properties. So I don't have any IP address. See, I don't have any IP address. So, but you can check your LAN card information with command prompt. If you check your IP config, you can see this is your Wi-Fi LAN card. You can see this is what VMnet one. You can see I'm automatically getting IP address which is start with FE8. I'm not using IP, but you can see I'm automatically getting IP address from this range, FE8. FE8 is what? FE8 is what? It's a link local. So every IPv6 enable interface will get this range of IP. It means this is what? This is link local IP. Aniket, clear? Fabian, Sumit?
Yes, sir.
Yes, sir.
How to
Yes, sir.
configure IPv6? How to configure IPv6 address? So we have two options. Okay, for example, I have IPv6 and I want to configure. Topic is what? IPv6 address configuration. Configuration. So how to configure IPv6 address in Cisco router, in Cisco switches? So you have two options. You can configure IP address statically like IP version 4, or you can go with dynamic option. Dynamic. In dynamic, we have two topic. In dynamic, we have two topic. We can go with stateless, auto configuration, and we have stateful auto configuration. So stateless and stateful. Get my point? So this stateless is what? This is called via UI 64. And stateful is what? Via DSCP V6 server. Okay, I'm only giving you idea. Aniket, these are what CCNP related concept. Clear my point? Aniket, Fabian, Sumit.
Yes, sir.
We'll discuss static IP address configuration, no problem. But these options are related with CCNP training. Let's configure IP address statically. Okay, so let's create a topology. Wait, give me 2 minutes. Okay, let's create a topology, okay, for our IPv6 address configuration, and we can also focus on IPv6 routing implementation. Okay, I want to configure routing in IP version 6 network. So let's create a topology. Okay, let's design our topology. So here I'm using 2001, colon 10, colon 1, colon 12, colon 1, slash 64. Any problem into this IPv6 format, Aniket, Fabian, Sumit?
No, sir.
Aniket for you?
No, sir.
Fabian? Okay.
No, sir.
Okay, let's configure same series of IP on this directly connected interface. So dot two. This side I'm using 2001 colon 10 colon 1 colon 23 colon 1. And this is your directly connected. So I'm using 23 colon 2. For roots, we can create loopback interface IPv6 to 2001 colon 1 colon 1 colon 1 colon 1 slash 128 loopback interface. Let's create loopback interface here. 2001 colon 1 colon 2 colon 2 colon 2 128 single loop back interface. Now 2001 colon 3 colon 3 colon 3 colon 3 slash 128. Okay, let's configure IP address as per our design first. Okay, wait. Let's configure IP address. So IPv6 address. Everyone. Command syntax is what? IPv6 address. And let's copy, okay? Let's copy this big IP address and we can paste here. No shutdown. Done. We can create loopback interface loopback 0 IPv6 address. And you can paste your IP address information. So this is your IP. And this is called prefix value. This /64, you can say prefix value. In IP version 4, you can type complete mask. But in IP version 6, you can type prefix value. Press enter. Show IPv6 interface brief. So yes, we have IP address on 0/0. IP address on loopback interface. Yes. Let's go to part 2. Interface fast Ethernet 0/0. IPv6 address. We can paste our IP. No shutdown. Interface fast Ethernet 0/1 IPv6 address. Copy. You can paste. No shutdown. Let's create loopback interface. IPv6 address. We can copy. And we can paste. Show IPv6 interface brief command you can use to verify your IP address configuration. See, IP address on 0/0, IP address on 0/1, IP address on loopback interface. Let's go to R3, 0/1 IPv6 address. You can copy and paste here. No shutdown. Now interface loopback 0 IPv6 address. We can copy this big IP and paste here. Now show IPv6 interface. Simple. How to configure IPv6 address in Cisco routers? Aniket, Fabian, Sumit. Simple configuration.
Yes, sir.
Yes, sir.
Okay. Now into this topology, let's try to implement everyone static routing, default routing, and dynamic routing. So after this topic, now you are familiar with IP version 4 routing concept. And after this topic, IP version 6 routing. Both you can implement. So we can focus on RIPng. Here we have RIPng. Here we have EIGRP and OSPF version 3. OSPF version 3. So let's try to configure dynamic routing protocol first. Dynamic routing protocols. And I'm trying to configure RIP protocol into this topology. So routing configuration is difficult. Routing configuration is difficult in IP version 6. Aniket. Fabian, Sumit. It's a difficult. Okay, let's configure. Okay. So command is what? Remember IP version 4, everyone. RIP configuration router and then RIP, right? This is the IP version 4. But in IP version 6, now you can type IPv6 router RIP. And now here we have RIPng. Okay, we don't have RIP only, it's called RIPng. RIP next generation. So in RIPng, command syntax is a little change. There's a little change in command syntax. You can give a name here, a process name. Now in IP version 6, if you want to implement RIPng, you can give RIP process name. Like in EIGRP, we have autonomous system number. In OSPF, we have process ID number, and we need to use same autonomous system number or same process ID number on each routers. Here we have process name and RIP. If I'm using process name, for example, CCNA, same process name you need to configure on R2 router and on R3. So you can press enter. If you press enter, you can see you are getting a message, IPv6 routing not enabled. IPv6 routing not enabled. So by default, only IP version 4 routing is enabled on all Cisco routers. Okay, you have to enable IP version 6 routing. Command is IPv6 unicast routing. With this command, you can enable IP version 6 routing feature. Let's enable on R2 router IPv6 unicast routing. Let's go to R3 IPv6 unicast routing. Now let's go to R1. Command is what? IPv6 router RIP CCNA. Now I'm not facing any problem. You can exit. You can go to exit. And now you can apply this RIP on interfaces. So on R1, we have one physical interface and one logical interface, right? So let's go to interface fast Ethernet 0/0 and command syntax IPv6 RIP. And what is process name? CCNA enable. Done routing. Done routing. Aniket, Sumit, Fabian. IPv6 routing is very simple. It's not difficult. I was just joking, okay? It's a very simple. See? Now you can go to loopback interface. Interface loopback 0. IPv6 RIP CCNA enable. Done. Done your configuration. No need to advertise your network. Aniket, clear my point? Remember IP version 4, Sumit? Aniket?
Yes, sir.
Yes,
Have
sir.
to advertise in IP version 4. Fabian, you have to advertise your network, right?
Yes, sir.
But in IP version 6, you can just apply. You can just apply your protocol on interface. That's it. No need to advertise this big IP in protocol. No. Let's go to our IPv6 router RIP process name CCNA exit. IPv6 router RIP CCNA exit. And we have 3 interfaces here. 2 physical interface and 1 loopback interface. Okay, so let's go to IPv6 router RIP CCNA. Oh yes, command is already. Let's go to interfaces. So we have 3 interfaces. So I'm using range command. Range command. Range fast Ethernet 0/0 -1 comma loopback 0. With this command, I'm in 3 interfaces. Command is IPv6 RIP CCNA enable. Done. Let's go to R3. IPv6 router RIP CCNA. Now, interface range fast Ethernet 0/0 comma loopback 0. IPv6 RIP CCNA enable. Done. Done. Let's verify here. Show IPv6 route RIP. So you can see now you are receiving some root information. You are receiving some root information from R2, I think. Yes. Please wait. Okay. You can receive root information from R. Oh, wait. I think I'm using 0/1. This is 0/1 interface. IPv6 RIP CCNA enable. Now we can check our routing table this time. So yes, I'm receiving loopback network information with R flag loopback interface information. Let's try to ping this loopback IP. Done. Done, everyone. Aniket, Fabian, Sumit.
Yes, sir.
Let's try to configure EIGRP. So wait, I'm trying to remove RIP. No IPv6 router RIP CCNA. Let's go to R2 router. No IPv6 router RIP CCNA. Let's go to R3. No IPv6 router RIP CCNA. Now let's start our EIGRP configuration. So IPv6 router, IPv6 router, EIGRP, and autonomous system number. Now you can type here no shutdown command. No shutdown command. Now we need to create IP version 4 loopback interface also. One IP version 4 interface in case of EIGRP and OSPF. Otherwise, they cannot form neighbor relationship. So in IP version 6, RIP configuration, and for OSPF configuration, you need IP version 4 interface. Why? For router ID. Without router ID, they cannot exchange information. So what I'm doing, I'm going to loopback interface, loopback 0. Okay, and yes, I'm using IP version 6 IP. Let's configure IP version 4 also. So 1.1.1.1 mask. Let's go to R2. Let's go to R2 interface loopback 0 IP address 2.2.2 mask. Let's go to R3 interface loopback 0 IP address 3.3.3 mask. Now let's go to R1. And now IPv6 router EIGRP IPv6 router EIGRP and autonomous system number, no shutdown. Now you can go to these two interfaces. So range command we can use 0/0, loopback 0. Now IPv6, EIGRP, and autonomous system number. Done. Let's go to R2. R2. IPv6 router EIGRP autonomous system number. No shutdown, exit. And now interface. Range. I think we are using range command here. Wait. Range. Now IPv6, EIGRP, and autonomous system number. Let's go to R3. R3. So IPv6 router EIGRP autonomous system number, no shutdown. And now we can go with range command. Yes. IPv6 EIGRP autonomous system number. So routing configuration is very simple in IP version 6. Only format is difficult to remember. IP address is big, but routing implementation is easy. You can configure. You can verify. Show IPv6 route. So you can see you are receiving route information with D flag. D flag is what? Dual algorithm EIGRP protocol. Okay, let's configure OSPF. Wait. So no IPv6 No IPv6 router EIGRP 10. No IPv6 router EIGRP 10. Let's go to R3. No IPv6 router EIGRP 10. Now, let's use OSPF. Remember OSPF, everyone? In OSPF, we have area concept. And we need to create area 0 first. Area 0 is called backbone area, or you can say transit area. So what I'm doing, I'm trying to advertise all the devices in OSPF area 0. Clear my task, Aniket, Fabian, Sumit?
Yes, sir.
So IPv6 router OSPF process ID, just type exit. Now you can go with range command. IPv6 OSPF process ID and these two interfaces. I'm trying to advertise in area 0. Done. Let's go to R2. IPv6 router OSPF process ID. Now range command, yes. IPv6 OSPF process ID area 0. Let's go to R3. IPv6 router OSPF process ID. And now yes, range command. IPv6 OSPF process ID area 0. Done. Let's verify. Show IPv6 OSPF neighbor. Yes. Remember our OSPF 7 stage process? Remember our OSPF 7 stage process? Right now it is in a Xstart state. They are in Xstart state. Remember init, two-way, Xstart, exchange, loading, full. Now they are in full state. You can verify your routing table, IPv6 route. Yes, I'm receiving route information from R2 and R3 is taking time. Yes, it's taking time. Yes, I'm receiving. This is our IPv6 implementation. I hope it's clear. Aniket, Fabian, Sumit.
Yes,
Yes,
sir.
sir.
Yes, sir.
Okay, let's discuss our next topic tomorrow, everyone. Okay. And tomorrow we'll start our training at 8:30 because I have a new batch at 7:30 to 8:30. So now our timing is fixed now. Aniket, Fabian, Sumit, please connect tomorrow at 8:30 p.m. IST time.
Okay, sir.
Okay, sir.
Okay. Bye, everyone. Take care, guys. Good night,
Bye,
everyone.
sir.
Bye,
Bye.
sir. Thank you,
Bye.
sir.
Okay, sir.